Okay, so hi everyone and welcome to the ZarhusBMC, the second encounter. And we will talk today about porting OpenBMC to X11SSH platform. One moment. So let's start with who am I? I'm Mateusz. I'm a former system software development engineer at Intel, where I mainly developed MDA utility. And I'm currently a junior embedded systems developer at 3MDev, but I'm not the youngest member anymore, or at least not the freshest member. And yeah, let's go straight to the content. So let's briefly discuss the agenda. We'll talk what previously happened on the Zarhus Developers Meetup, I'll recap what happened in Zarhus BMC space. We'll talk about the issues we are currently facing. We'll talk about the progress and a little demo. Yeah, and the last point will be next steps and ideas. Yeah, so regarding what happened last at Zarhus BMC. During last developer meetup, we discussed what OpenBMC is and what its role in the proprietary world of computing. And to those who didn't make it to the last developers meetup, the BMC is basically another computer under your computer. So its role is to allow you to manage your main host. Yeah, and for the last developers meetup, I built and showcased the OpenBMC, and I managed to run it on the hardware. So that was pretty cool. And also I got access to UART, but I couldn't log in into WebUI. So during the demo, I just showcased you the login page. And that was because I had to remove some functionality in order to make the image fit within the sizes of the flash memory. And I removed actually the user management. So I couldn't create user to login. But since then I fixed that, and we'll talk about it. Yeah, and we can probably go to the next point. Yeah, so I rebuilt the image with user management support and got to ditch something else. So I ditched logging because who needs that, right? And then I was able to log in via WebUI. But this revealed issues, unfortunately. So TLDR, the two major issues revealed themselves when I managed to actually run the image. And those two main issues were KCS service and power control service. Yeah, let me see what else. Yeah, so basically the KCS issues relied on lacking KCS interfaces definitions in device tree structure. And this resulted in lack of communication with the hosts. So I could basically log in into the web UI and I couldn't really do anything because there was simply no connections with the hosts. And to those who don't know what DTS is, it describes basically the platform's hardware. They can be supplied by vendor or made according to the docs or even reverse engineered. But it is not something that you create yourself on your own. Yeah, and yeah, basically in our device tree structure, we lacked the definitions for the KCS interface. So it wasn't created since we didn't have the communication with the host. And the second major issue was lacking GPIO definitions, and we couldn't, as a result, we couldn't control host power states. Yeah, so basically the BMC SoCs have like GPIO. We could make a comparison to microcontrollers. They basically have GPIOs, but but many more. And those GPIOs probe various endpoints on motherboard or set those endpoints. And unlike the KCS addresses, each vendor can basically wire the SoC to their own liking, because for KCS we are missing some addresses, but they are pretty standard among all the ASPIDS BMCs. But for the GPIOs, the vendor can, as I said, rewire the BMC whatever they want, and thus it is not something that you will find in the documentation of the BMC. Yeah, and we've got some definitions, but they are not sufficient, and it's worth mentioning that they were a work of the man called Ken Fisher, and they were supplied as a part of porting the UBMC for X11SSH platform. But yeah, they were basically not sufficient for our case. And those are the two main issues we are facing. The KCS interface issue, which we will talk about resolving it later, and the GPIO issue, which is a bit more trickier. But despite the issues, we also made some progress. So first of all, let's talk about the community efforts we made. We've got the great positive feedback regarding the first meetup, Zarhus Developers Meetup. And also we, as Piotr said, opened the ZarhusBMC GitHub discussions to also make ourselves more transparent, but also to directly collaborate with the community. And yeah, that was a positive, massive feedback, I guess. And regarding the practical stuff. So we performed stock firmware scoping. First method was using binwag to disassemble the stock firmware and use QEMU emulation to run the stock firmware on whatever platform you wanted to run it on. And our expectations was to find some DTBs, so device tree binaries or GPIO definitions we were missing, or even do some interface scoping. But unfortunately, while we succeeded partially, it was doubtable how trustworthy were those results, because when you emulate such a firmware, basically there are lots of services failing, and it's hard to tell if you can trust that results. So the second, I think, bigger progress we made was we obtained UART access for the stock firmware. So we followed the Ken Fisher's work, the same guy who is responsible for UBMC port, because he discovered by probing the board physically where is the UARTX pin on the motherboard. And we also got the Gerber files for X11SSH from Team Ansel. And this way we were able to find the matching RX pin for the UART according to the datasheet we got. And this allowed us to gain stock UART access for stock firmware. Because on the first meetup, I also showcased you that we got the access, but we got the access when we built a custom OpenBMC, and it featured custom UBot, which got some pins redirection, and basically this method could not work for the stock firmware. So we got the access to the stock firmware by UART. We could probe it. Yeah, and let's go to the next point. And thanks to the fact that we got access to the stock firmware via UART, we could probe it on real hardware. So the method was simple, was to check binaries, check sysfs for if we could manipulate the GPIO pins or at least read their state. Yeah, and also check if we could read the platform state. And our expectations were to confirm suspicions and access possibilities. Yeah, but while all devices started properly, and how do I say that? There weren't really there weren't many things to scope. There were binaries, some precompiled binaries that were unusable because they gave segfaults, although there were some that were clearly marked as tools, but they weren't much use for us. And there was also one good point of probing the system running on a real hardware is that we could check the GPIO registers. So what this allowed us to do is basically put the platform into various states and check how the GPIO registers change. And since we have to in the future assess the GPIO definitions, it would greatly reduce the number of GPIOs we have to probe, because there are like 200 and something GPIOs on the Alspeed AST2400, and this basically reduced this number to like about 15. So it's a much of an improvement. Yeah, and I prepared a little demo. It's not much, but I think I can showcase you that we indeed have access to the stock BMC firmware. Right now we are on RTE, the platform that Piotr was talking about, and we will use the Minicom to connect to the UART adapter, that's connected to the X11SSH platform. And if you can go back a bit, yeah, you can see on the picture on the bottom how I hardwired into the platform, and this is basically how we got the connection. Yeah, but let's go back to the console, and we are already in the prompt. So yeah, the thing with the stock BMC hardware is that it is maybe not very old, but it's built on old kernels. So if I type uname r, you can see that we are running on Linux kernel 2.6.28.9, which is really, really old. And also it is that old that it's pre-device tree era. So it uses the attack mechanism that basically provides like a basic information for the platform, for the firmware to just assess on which platform it is running on, and all the support is built directly into the kernel modules. Yeah, we could also try seeing what GPIO SSFS interface looks like, but it's also isn't what you expect. You can't control the GPIO this way, and it's really, really basic. So yeah, the access is there, but the probing proved that there is not really much, but what we can do by simple methods. And yeah, for the fun, let's maybe put the platform in some states. Oh, it probably kicked me out, but let's try again. And what I wanted to do is basically put the platform in some different states. So you can see that the host is currently on. We can see like a grab prompt or something, and let's just power it down. And let's see, oh, sorry. Where is the console? Ah, yeah, it's just the console. And yeah, we are basically seeing something happening, right? Like some addresses or something. But this is like a debug information, and I scoped it too, and it really isn't much of a use for us, unfortunately. Yeah, so that's the peek at the stock firmware. And let's go back to the presentation, because I don't think that anything fancy will happen here. So let's switch back to the presentation. So how about talking about our ideas for the next steps? First of all, we have to attempt configuring KCS in the device tree. I told you that those addresses can be fetched from the documentation, and we just have to test that theory. Basically, it will involve adding, lacking KCS interfaces into the device tree structure and seeing if this will enable us to talk with the host platform. We also have to perform probing from the host side. Piotr talked about possibly developing some tools to automate the BMC porting process. And as a part of preparation, we also want to try gaining some information from the host side for what we can learn about the BMC this way. Yeah, we have to address the GPIO issue, but this is like a hard knock life. It's a hard task to perform. I don't know yet how successful it will be, but we will definitely try it. And yeah, maybe develop some tooling for easier porting, wink wink. And more platforms await, but I think that's a bit of secret topic for now. Yeah, and that's basically it for my presentation. I got to mention the Ken Fisher once again, the man who ported UBMC for the X11SSH platform. Without his work, most of the stuff I was able to do to be done wouldn't be possible. And also special thanks to Team Ansel, who provide Gerber files for the X11SSH. And yeah, if you are interested in the topic, the management will probably find a way to give you the presentation. I also forgot to fix the blog post link, so sorry, I will fix that when it's published. And yeah, also, if you would like to learn more, you can check out the ZarhusBMC discussions pane on GitHub. We will post there any updates we will do to ZarhusBMC. And also, as a point of honorable mention, you can check out the Ken Fisher's blog post and Team's Ansel's Gerber files. And yeah, that's basically it from me. And I think it is the time for the questions.
And I have a question, 2 questions actually. What are the KCMs?
So the KCS, right?
KCS, okay.
Yeah, so KCS is a physical interface. It is like the really legacy one because it comes from the 70s, if I remember correctly. Yeah, but it's a simple interface in which both host and the BMC are able to control the hardware features of the platform. And it should be noted that this is the physical interface, and the protocol that we will be using to talk from BMC to the host is called IPMI. Yes, so KCS is a physical interface.
Okay, and the second one, what are the Gerbers?
So the Gerbers are basically the files that these are schematics for the PCBs. They basically show you layer by layer the connections on the PCB, and if you trace them back, you can learn some stuff like I learned how the GPIOs are wired, and found a blank path I could solder to gain access to the UARTs.
Is it just the way you call it, or some actual
No, I
terminology?
think that's the standardized name. I think the extension is Gerber or something like that. Yeah, but
okay.
I
Yes,
think that's
it's
the particular
official,
name.
and it's more like a production files that you send to the PCB manufacturer to produce your PCB board. You provide them with Gerber package, and they can produce PCB according to that.
Yeah.
Okay, thank you.
Okay. Thank you very much, Mateusz. Like that was really good. I hope that we can push that forward. I'm not sure if on X11 we will see, because it still seems to need a lot of care, a lot of love to push that forward. So one thing is KCS, but second is the power cycle. Yeah. So those are two biggest blockers.
Correct. Yeah. The issue is that we don't have the GPI definitions, and as I said in my presentation, these aren't really. We can't find those in any of spreadsheets, right? We have to, I believe, figure them out by ourselves.
Yes. So my kind of idea here is if you will have, I believe in following scenario, that if we will see enough amount of different power cycling scenarios, we could kind of better approach it and better understand how to realize and where to look for information for this power cycling. So that's why I'm looking at this. So if you when you show this serial log when it booted, so there was mentioned like CPLD something. So I guess like the CPLD is responsible. So it was like pre you can say pre FPGA era kind of programmable gates. So CPLD was one of like that you program it to make sure that the power cycling on the platform is correct. So I guess the knowledge is inside there somewhere. of course, like without knowing the schematics, kind of reverse engineering that is complex, that's obvious. But I think that if we go ZarhusBMC path, we have to educate ourselves regarding how this FPGA work and how to power cycle so massive systems. Yeah, and that's part of education for bringing that ZarhusBMC to the public. And this knowledge, I think, this knowledge is right now tribal knowledge, so that's the problem. And I think we have to kind of open that. Like that's part of our transparency mission in embedded environment. But that's just a comment. We already should start with the next presentation. So thank you very much for all the discoveries that you made. And we start with Michał's presentation about securing embedded Linux.